Okay, so we're going to talk this unit about solving exponential and logarithmic equations. And the first one we're going to talk about is the easiest one. Well, I think so. We're going to talk about solving exponential equations, and this is when they have a common base or without a common base that we can change to be a common base. So the first thing to know is that when we're talking about exponential equations, we're talking about exponents. We can use properties of exponents to simplify each side of the equation. You want to get one single number raised to an exponent is equal to one single number raised to an exponent. And we want that, hopefully that number to be the same number. We're going to use the product rule a lot, or the power rule. So just remember that the product rule states that if you have the same base, which is why we're trying to get the same number, and they're raised to, it can be different exponents, the product rule states that we add those exponents together. The power rule states that if we raise an exponent to a power, then we multiply. Okay, so when we're solving these problems, we're going to use these different equations. I forgot one more. Another one that we need to know, this is more handy when we're talking about equations without a common base, is that if we have a negative exponent, remember that just makes it a fraction. It doesn't make it negative, it just flips it and makes it a fraction. Okay, so when we're solving exponential equations, we want to use these properties so that we can just get a single number on either side, a single base on each side. Then we're going to rewrite the equation so both sides have the same base. If they don't already have the same base, because some of these will, then usually we're going to find, is there a way that we can write it as the same number raised to a power? And then step 3, we drop the bases, and then we just set the exponents equal to each other, and we should have a really easy equation to solve. So let's look at type 1, which is the best one, and that's equations with a common base. So you'll see that each base is a base of 3. So that means all we have to do is combine this left side so we have a single base of 3, and then we can drop those 3's and just solve for our exponents. So if we do this product rule, right, we're going to have 3 to the k plus 2, and that equals 3 to the 5k minus 1. So now we have single base equals a single base. We can drop that base of 3, and we're just setting up an equation with our exponents. So we have k plus 2 equals 5k minus 1, and so we get 2k plus 2 equals 5k minus 1. And then let's go ahead and subtract 2k, add 1. We're going to get 3 equals 3k, divide by 3, and we get k equals 1. If we wanted to check this, we can see that 3 to the power of 1 times 3 to the 1 plus 2 is equal to the 5 times 1 minus 1. So this would be 3 to the first power times 3 cubed is equal to 3 to the fourth power. And you'll see that that's 3 to the fourth power equals 3 to the fourth power. So it does work. All right, so let's talk about the second case, which is not as easy, but what we're going to do is really just make it super easy. So we're going to make it have the same base. That's our goal. So we just have to do a little bit of rewriting and some math and some problem solving. So what we have on this first one is we have 7 to the 4x plus 11 equals 1/7. So we want to rewrite this one so it's a base of 7. We don't have a whole lot of work to do. We can just raise this this is the same thing as 7 to the negative 1, because remember it's that negative exponent rule. So let's rewrite this now as 7 to the 4x plus 11 equals 7 to the negative 1. And now we can drop this base of 7 because that we have that single base. And now we have this, we just solve for our exponents. So 4x plus 11 equals negative 1. And let's subtract 11 from both sides. And we get x equals negative 3. Super simple. All right, let's look at the next example. So this one's a little bit harder. We have a base of 27. We have a base of 3. But I know that 27 can be written with a base of 3 because 27 is the same thing as 3 cubed. So I'm going to rewrite that as 3 cubed, and that is raised to the power of 2x plus 6, and that equals 3 to the 2x. All right, so I'm going to remember my power rule, which states that I have to multiply. So this is 3 raised to the power of 3 times 2x plus 6 equals 3 to the power of 2x. I can drop that base of 3. And now I have an equation 3 times 2x plus 6 is equal to 2x. And let's solve this equation. I'm going to just multiply by 3. I get 6x plus 18 is equal to 2x. So let's go ahead and swap this. So I'm going to move 2x over and 18 over. So I get 4x is equal to negative 18. I divide both sides by 4. And that means that x is equal to negative 18 over 4. I'm going to simplify that. And that means that x equals negative 9 halves. All right, let's look at our last example. So in this one, we have 2 base 9s, and then we have an 81. And remember that is 81 is just 9 squared. And since it's a fraction, that means that this is just 9 to the negative 2. So let's combine this left side. That's going to be 9 to the 2x plus 4 plus 2x, and equals 9 to the negative 2. So now we can drop those bases of 9. And our equation is going to be, let's combine those x's. 4x plus 4 equals negative 2. And now we solve. Subtract 4 from both sides. We divide both sides by 4, and we get x equals negative 6/4. Of course, we want to simplify. So that gives us negative 3 halves. And there's our answer. So super, super simple when we can change the bases to be the same, or if we're already given them with the same base.